Okay, people joining this live stream. I am out on the road today, so different resolution of screen, but we are doing a Wolfram Language incremental development meeting, and we've got a number of things which are hopefully getting closed off in time for version 12. So first up, we have percent form, and I assume I can run that. I assume that I have a version 12 here that I can run that in. Is it in the head branch build?
We merged it to some changes today, but most of it should work. I mean, it has been merged since quite some time ago.
Okay. It's kind of odd that my computer is refusing to charge. That's a different issue. Okay. Okay. By the way, what's this tag geovector and whatever is protected that looks like a bug in the today's build?
I'm looking at it. Yeah. Thanks.
Okay. Prints with numbers and expert given as percentages. Looks good. Okay, what questions are there here?
First, you can have a look at some examples. And we did change the period, for example, in the first example.
Excellent. It's beautiful.
And one thing that was needed during this work was that we had to generalize one option of number form called sign padding. It was a Boolean before. Now it is now it can be a double Boolean, a list of left and right. So this is following what number padding does and what number sign does. They are both double Booleans. I don't know why it wasn't done from the very beginning. It's very natural to have all of them.
Yeah, okay. I don't have a problem with that. Can you adjust the documentation?
Yes, we can do that.
I think we pretty much did for the example with the counting form is where it's relevant.
No, I understand, but sign padding has not been updated, right?
Yes. We will do that. We just wanted first to check with you.
Yeah.
Yeah, I don't see a problem with that.
Mm-hmm.
Okay. Where are we knitting percent form? Do we know?
Wherever number form is.
Yeah, probably. I mean, I think it's a really good function, so I think it's something here. I will do the honors of defuturizing. Well, and decimal form also. So I assume decimal form points to percent form.
Probably not yet. We haven't done knitting here.
Okay. Okay, I mean you'll probably do more knitting.
Yes.
And let's take a look. Well, there seems to be a thing called display of numbers, as well as number digits. Where's decimal form on that page? Ah, there. Let's just mention it here. Why is that beeping at me? It's really odd. Weird. Oh, maybe I didn't start DocuTools here. display of numbers. Where is decimal form? Oh, display without scientific notation. Okay. I think this is important enough that it should get its own little section here.
Section, not just a line. I see. I think a line.
Well, I think a line is okay, but I think we should separate off these ones because these ones I think are a little bit different. So let's just say
Oh, I see what you mean. Yeah, probably accounting form should be with that first group.
Yeah.
The other ones, C form, do look different.
I'm prepared to put accounting form down there. I don't think it's very commonly used.
Okay.
However, accounting form should certainly point to percent form. Another thing that should point to percent form and percent form should point to is stuff about units. Where's the page about units? The things about displaying, what's the thing that displays units in a particular way?
Quantity form?
Yeah, I think that's what I was talking about. And this, by the way, quantity form should probably be mentioned here. Yeah, I think this should mention, before style, should mention percent form. And here, we should have a thing for saying, displaying quantities. I mean, arguably, this should go someplace else on this page. We'll specify how units, etc., should be displayed. Is that right?
Yeah, I think so.
Yep.
Right. So probably it's more quantity form than quantity, or both.
No, I think both. Okay. All right. There may be a little bit more knitting there, but that's check the backlinks on some of those functions,
right,
like scientific form and so on, accounting form. Oops, something beeped there. Okay. Ooh, what was that? What just happened there? That was another version that had been opened somehow. Let me open this agenda in 12.0 here. Hold on 1 second. Just 1 second. Okay. All right, let's go on to the next thing. Keys values second argument.
Yes, so the idea here was to be able to wrap something around the values like extract does. This is useful when there is holding needs or evaluation problems.
Yes, I think this looks good.
Mhm. Yeah, we have added examples, and there's nothing to need here.
Maybe there is actually in the section about doing things without evaluation. Let's check. Did this match to hold, for example? Did we map this? We might want to wherever we discuss hold. This is relevant, I think.
Okay. Evaluation control.
Oh yes, Sandra on our live stream mentions that the percent interpreter should also mention percent form. Can somebody see to that, please?
Yes. Yeah, with extract.
What does this gray mean?
I don't know.
I think it means don't use this as a primary. What's that?
I think it's excised.
Is it? I think it may mean don't use this to tag backlinks.
I see.
How to say this?
Without evaluation, like the previous ones.
All right, that will need formatting work, Sushma. Sushma, Sandra on live stream asked, does percent form work with percent quantities? What's the answer to that?
But percent quantities already, well, it's probably going to show percentage twice.
Okay, so if I say this percent, okay, and now I say percent form. Oh, that is not good. What does that mean?
Well, it's multiplying by 100.
But it's wrong.
But it's
because this, I mean, how do you get rid of this? Do you say normal of that?
Yeah, normal will turn it into a integer
Okay,
value.
so that is a bug, if I might say so, guys. Percent form really should work with percent quantities and not do the wrong thing. Simply impose its, it should simply impose its, what am I saying? It should impose its formatting and then get away, so to speak.
I'm not sure, because if we have any other unit, it should work, right?
Well, what should it do with another unit?
Change the percent to meters.
Okay. Well, actually, why don't I change it to, could we, background noise, please, guys? Let's change it to degrees. Background noise, please. Could you get rid of it? Okay, so that's very screwy what that did.
Again, I think this is correct, because it's multiplying the number by 100, adding the percent, and then it has the unit outside.
Okay, but this is clearly not correct. The percent form of a percentage quantity.
So I think it's following the general rule, but we can add an exception here that would have to go into the code of percent form of be careful with quantities or something like that.
I think that's what we have to do, yes. Now, is there any other, I mean, because I think that case is not what you would expect, right, with percent, and certainly not the double percentage thing. Now, what happens if we do things like per mil? Don't we have that in here?
I guess so.
Okay, so now the percent form of that per mil thing, what should that be? Incidentally, one extension of percent form that we might consider at some point is to, do that, is to allow things like per mil and so on.
I'm thinking that perhaps the right thing to do here is not to let percent form go inside quantities.
I don't think that would be bad.
I think I agree. I mean, I think these are pathological types of input, and not allowing percent form to go inside hardwiring that would be just fine.
Which just means it just leaves whatever the quantity said.
Yeah.
And percent form just does not affect the number. Yeah, that's the right behavior.
That would be my preference.
Yeah, I agree. That's the right behavior.
There are already some exceptions, like don't touch fractions and things like that. So
fine. Then just add that exception,
right,
and document it.
Okay.
Okay. Okay. Integer fractional part.
Yes, we added recently numerator denominator. So this is same type of thing.
Only far more controversial.
Well, yes, we've got some comments. We've got some comments saying that the right way to do this is to implement it to be twice as the same speed as
to not destroy packed array capabilities. So the integer part would return the same type as the input.
Right. This is a really weird name. I have no idea what that I see. Integer fractional part. I didn't know what that meant. I mean, I understand it now that you've explained it to me.
Well, we can give it another name.
And what's the issue with the packed array thing? I mean, that's an implementation issue, yes?
No.
Yes.
No, it's a design problem. It's fundamental.
Well, what's the issue?
For every number, we are going to return a pair. And that pair for machine reals is going to have an exact integer and a machine real.
Okay, so, I mean,
So
that's what it's returning. Okay, but that's what it's returning.
Right.
Well,
so I think it's an unavoidable feature of this function.
Yeah, that means it's going to be much slower on packed arrays.
So what? It's an unavoidable feature of this function. So there's nothing more to say.
I'm pointing out.
There's nothing more to say. I mean, it just doesn't, yes, eventually we'll be able to pack those things and then this will pack. But until then it won't, because it's returning, as you say, an exact number and a machine integer. Now, the only thing, it's a really kind of a weird name.
Yes, it's following the tradition of re-im numerator denominator. But in this case, we are already breaking it because it's not integer part, fractional part. So I'd be fine with giving it another name.
Like integer part, fractional part.
That's really ponderous.
I'm not being serious. What I would like, what it's doing for rationals is converting more or less to a proper fraction, but I don't think we can use that terminology.
Yeah, I mean, it's as in it's converting to a mixed fraction, right?
Okay, sure. I believe that's correct term. It's mixed versus improper.
By the way, we are hearing a lot of background noise from.
If Lou sneezes again, I'll just shoot him.
No. It's just you seem to be on speakerphone there.
I'm not. I'm on my headset.
Okay. what would happen? Well, the problem is we might imagine a wrapper mixed fraction that represents, 3 plus. I mean, we have that weird thing, don't we, for invisible plus? Or did I misremember that? There's an operator that you can put in the middle of a mixed fraction. Am I making sense?
I don't know it.
I don't recall this.
Yeah, it's there in the typesetting system. So, I mean, to me, calling it mixed fraction parts,
Or pair.
Could do that.
mixed fraction pair, mixed fraction parts. Someone is saying MI mixed fraction is a bad name, but I don't know whether they. So let's recall what this thing is doing. So it is turning something into a mixed fraction, but it is not a mixed fraction form. I mean, this would be more like 2 mixed fraction, except that it isn't really a mixed fraction because it's a pair.
Well, the idea of a mixed fraction itself would be a formatting form. But
yes, I understand. Yeah. But mixed fraction pair, see, I'm thinking about elementary users where this might actually be, I mean, they're never going to do integer fractional parts.
Right.
In fact, mixed fraction parts was something you'd suggested, right?
Mixed fraction parts, yes.
Okay, yeah, I could go with that.
Do you think that's better than mixed fraction pair?
I prefer pair. It's more specific about returning always 2.
I wonder whether these things have a name in the elementary math literature. What do you call the 2 pieces of a mixed fraction in elementary math literature?
The integer part, 2 words, and the fraction part, or rational.
A mixed number, a mixed fraction from the at least we have something on Math World that's more encouraging. Mixed fraction is an improper fraction written in the form n plus r over s. Let's see whether people have a name for this. A mixed fraction is a whole number and a proper fraction combined. Well, okay, so the question is between mixed fraction pair and mixed. I think having mixed fraction in the name is the right thing.
Yeah, I like that.
So the only question is it mixed fraction pair or mixed fraction parts?
I'm starting to lean towards pair, although still thinking.
I do prefer pair.
I'm just looking up here. The only problem is that then it might be a pair of mixed fractions.
Okay. What about mixed fraction list? Well, it has the same problem.
It has the same problem, yeah. From mixed fraction? No, I don't like that either.
It would be from improper fraction, which is really long.
And the problem is we don't want to say to mixed fraction because it isn't actually a mixed fraction.
Correct.
Well, okay, so what are our choices? Our choices are mixed fraction pair, which sounds like it's a technical name, and mixed fraction parts. Which sounds a little bit less technical to me. It's the parts of a mixed fraction. Thoughts?
Well, using part aligns better with integer part and fractional part.
Good point. Let's go with mixed fraction parts.
Okay.
Okay.
Okay, let's do a rename here. Where is my rename button? There we go. Okay, let's check that we can write this correctly. Okay. Well, we could. This documentation could be left exactly the same.
I think so.
Okay. All right, let's defuturize. Now, I mean, this probably wants to find its way onto the elementary math pages. Let's not do this knitting right now. See if you can knit this.
Okay.
Unless, well, let's just see. Let's just see if we can find where integer part is. Numerical functions, integer functions, numerical functions. Wow. It's very prominent at the top there. I think we'd have to list it along with those. It's a little weird. Do you think we should list it as a whole line underneath there to explain what it is?
Where else could you?
No, let's just put it here.
Keep in mind that strictly speaking, it's not what we call a numerical function because it doesn't return a number.
But we don't have any other case like that.
I'm not sure.
Well, some of these numerical order certainly doesn't return a function of that type. I think it should go here. I mean, I might argue that it should be on a separate line because it's going to be incomprehensible here. Everything else on that line is totally comprehensible. I think it should be a separate line.
Yeah, I think so.
Do you want to say proper fractional part? Or is that too obvious?
That's pretty obvious. Okay, now this probably wants to go in. Gosh. I mean, really, it goes with these guys, doesn't it? It's a little weird putting it.
As in division-related functions, yeah, I could go there. It's a cousin to quotient remainder.
Yeah, but those are all much more mathy.
True.
All right, I think there's a page for more elementary functions. We should find that, but let's keep going on what we need to go through now.
Okay. Okay,
uncertainty, vector, yeah.
Yes, so probably our biggest change here recently is that working on the typesetting, it became clear that having the number case and the vector case is a problem because we don't want a vector plus minus a matrix.
Okay.
And also because the statistics team separates normal distribution from multi-normal distribution, I think we should separate around and vector around.
Wow. Isn't that I mean, what does vector around mean?
Vector around will take a vector in the first argument and a matrix, the covariance matrix in the second argument. So before, around was taking both a number in the first argument or a vector.
Why isn't it list around?
It could be list around as well. I think vector sounds a bit more.
Yeah, but why isn't it matrix as well?
Well, because we don't have a concept of the covariance of a matrix against itself. So a rank 4 object that's never used. So.
But so okay. So is there a page for vector around?
I've just added one. Very right. So the idea would be that those two cases were covered also in around itself before, but this was leading to a problem. For example, do you mean if you have a 2 case, is that the asymmetric error as well? So I think it's going to be a lot better to separate this case.
So hold on a second. So you were saying, so around itself has the possibility. So if I say around 23.5.
So this works in xkernel, but so right now, what I'm suggesting is that this will thread. This is the discussion we had recently as well of what to do with an array of arounds. So that is going to require yet another concept like quantities.
What the heck? That's a separate problem. Can somebody look into that, please?
Yes.
That's the xkernel.
Okay.
So there is a documentation page for around as well.
Okay. Well, let's try the around. So you say around 34, 0.5. You are proposing that. Okay, so
right now it doesn't thread, and I think it is bad.
Threading is a dangerous thing.
Why?
Well, I'm just thinking about this. I mean, okay.
I'm following quantity here as well.
What does quantity do in that case?
It threads. Now, this forces eventually the addition of quantity array. But because right now we cannot support around with a list in the list operations, it would be better eventually to have some sort of notion of around array, if needed, that is able to handle things fast, like quantity array.
Yes.
Because the other model to follow here is that of geoposition, which is able to hold all the numbers inside in the first argument. But geopositions are not a vector space. You cannot add them. So there are very few actual array operations you need with geoposition. But with quantity, you need all of them. And with around, it's going to be the same thing.
Let me understand your statement that they don't make a vector space. Why is that? I mean, they're not Euclidean vectors. I mean, why aren't geopositions? Go ahead, explain.
Imagine the geoposition of London and the geoposition of New York. What would be the addition of them? So in curved space, positions do not form a vector space. There is a vector space tangent to each point, and that's why we have the geovector family now, to describe that vector space attached to each position.
That's interesting. I mean, that's interesting. I'd never really thought about that before. Yeah, I understand. So there's no sense in which in curved space you can have positions form a vector space?
No. It's a general property. You have, in order to work with vectors, you have to go to the tangent spaces. And then you have vectors at each position. And then how you communicate the vector space of one position with the vector space of another position is a complicated thing that leads to curvature.
I see. That's the connection. That's when you have a connection.
Exactly. The connection dictates how to go from the vector space of one point to the vector space of another point.
Fair enough. Okay. I mean, that's kind of obvious, right? That yes. Okay, that's obvious, given that one knows that connections exist. Okay, I'd not thought of that before. That's a good argument. We should remember that argument for the next time somebody reports this as a bug.
Right. It has.
It's not our bug.
Right.
Okay. I agree with this argument. I mean, is there a notion? Okay, so the generalization of a round to, for example, a geoposition, what is that? Because clearly in a round of a geoposition is, that relates also to your geodistortion business and so on, right? Because the around of a geoposition could be, I mean, we obviously have geodisk, but if you have an uncertain geoposition, right, then you've got something which is a different, I mean, can you comment on that?
Yes. So eventually, geoposition should support around latitude or around longitude.
Yeah, but I don't think that's the right thing, right? Because I mean, in fact, around the North Pole, for example, right? It's what you actually mean is I want it to be I mean, this relates to the spatial statistics business as well. You want it to be, a kilometer of uncertainty around the North Pole.
I see what you mean now. Yes, so that's a connection with geodisk. So perhaps what we have there is a geodisk with a notion of
uncertainty and uncertainty radius. Yeah.
Yes.
So it will be geoposition around, roughly. So I'm using this to understand your vector around case. So, I mean, we don't have a lot of things that are called vector, this, that, and the other yet.
Right. So there will be a few now coming with the optimization, but this is different. Of course, we could follow multivariate, like the statistics does, or multi-around, like.
Oh no, it's horrifying.
But
that's
yeah,
totally obscure.
Yeah.
I mean, if we're going to do that, I think that the okay. So listen, the listability of around, I'm okay with that. Although, as you say, we're going to end up with an around array.
If it becomes critical to manipulate tons of this fast, I think that's unavoidable. Because otherwise, the operations will have to go one by one, like the same problem as with quantity.
Well, actually, no, that's not right. Because quantity, the whole point about a quantity array is it's the same unit for lots of things. With the around, it's not going to be the same uncertainty for lots of things. That's a rare case.
Yes, but my point is that we can hold internally a packed array of numbers and a packed array of.
Yeah, but that's our problem. I mean, we don't have to expose that to the user. The fact that some list of arounds could be represented internally in some packed form is our issue.
Yes, but we will need a representation. So this is
but
like
not necessarily at top level. It could be internal, just like a packed array is internally represented.
Yes.
Okay, so let's come back to the vector around question. Are you happy, given all the other vector, greater, vector, less, and so on, are you happy? This was added in this version, wasn't it? Vector greater?
Yes.
I'm not even sure I've reviewed that yet.
Cone inequalities. This is optimization.
Right, but is this consistent with vector greater? Is the vector around consistent with the way that vector greater is working?
Well, vector greater is comparing two vectors. So we could say that once we have vectors around, vector greater could compare vectors around and take into account that they have an uncertainty to decide whether they are greater or not, this sort of thing.
Yes. Well, there isn't a notion of greater for around numbers, right? What is the notion of greater for around numbers?
So
if I say this greater than around -3.1,
yeah, so
say it can't do it.
this doesn't work right now, but the idea is to compare the widths of the
Like an interval. So
exactly.
as if, do you think that's the right thing to do?
Well, there are two possibilities here, and I have been thinking quite a lot about them. So either we compare just the numbers, or we follow, for example, what numbers with finite precision do. Numbers with finite precision have some sort of threshold of overlapping, which is like 60% of the intervals, and then you consider that.
That's interesting. I mean, I would have thought we need to do something like that for these.
Mm-hmm. Yes. I'm also thinking that people will expect that if, for example, if one interval is included inside the other, we say yes. Of course, these are all things.
Wait. We say yes for greater or equal to.
For equal, exactly. I mean, this problem also exists with equal. When do we consider that two arounds are equal?
Yeah, I understand. As opposed to triple equal, double equal.
Right.
Yeah, that's tricky.
Mm-hmm. I mean, triple equal is clear. Double equal is the one which is kind of.
Yeah, that's a very interesting problem. We hadn't come up before.
Right. So my guide there is to follow what numbers with finite precision do.
Yeah, I think that's right. But what happens with sorting arounds?
Well, that depends on the numerical ordering. Sorry, on the ordering function you are using. By default, it will use canonical order, whatever canonical order decides already.
Yeah, I understand. But I mean, canonical order, just like, I mean, numerical sort has to decide, numerical sort should do something sensible for a round.
Right. So numerical sort is specialized in three things currently, which are numbers, quantities, and dates. So this is a fourth object that needs to be added there.
Yeah, right, with thought.
Exactly. Well,
okay.
Intervals as well. So numerical sort also handles intervals, especially. And I think there the decision. So there is lots of literature on ways of ordering intervals, and there are many ways, many different ways. And the decision right now is to be very strict. So if they are fully separate, we can say one is greater than the other one. But as long as there is one overlapping, even 1 point, then greater and equal will refuse to return true or false.
Okay.
That's the current decision.
Yeah, I mean, arguably, we want to have some kind of, we want to have some variance of the greater than functions and things. I mean, this is tricky.
I think greater equal should do something by default, which is relatively reasonable, like comparing a bit.
Yeah.
And then we may have more powerful functions later to talk about compatibility and are these compatible to so many sigmas or compatible to this confidence level, this sort of thing.
Yes, I understand. Or alternatively, we might end up with an option to greater, for instance. Okay, let's look at vector around, though. So I'm kind of warming to this idea of calling it vector, especially if you don't think you're going to be able to do higher ranked tensors.
No, I mean, I've never ever seen that done with I mean,
okay, so if you say x1, x2, and then there's a single uncertainty there, it will apply to all of them, presumably.
Yes. So one number would mean u is the same for all of them, but the general case here is a matrix, which basically means it's the squares of the previous one. So this is a covariance matrix, which means it's the squares of u's in the diagonal plus the correlations in the non-diagonal arguments.
It's very weird that it's the square of the. You're saying the u sub I is in the first case there.
Mm-hmm.
In the second case, the diagonal is the squares of those u sub i's?
Yes, that's the way to handle this.
That's exotic.
Yes, that has to be very well explained in there.
But that's not the case for an ordinary covariance. I mean, it's an ordinary. The matrix is not a covariance matrix normally.
It is. I mean, if you go to covariance metrics and statistics.
No, I understand. I'm saying for a round, the second argument of a round, normally, yeah, there's no covariance because there's only one there's only one thing.
Exactly. For a number, it's just one u.
Yeah, all right. This is convincing me that vector around has to be separate.
Yeah. It's not a matter of more functionality. It's just extracting functionality which was mixed in a round before to this function.
This is very good. This mean around, that's a very useful thing. By the way, I would do it without a random real here. I would just do, I mean, this is not a good example. Just do a mean around of a list of numbers.
Okay. Yeah.
Okay.
So,
okay.
So we can have a look at the page of around itself. So here, the main thing I'm still considering is how to call the parts. So right now I'm calling best value X and then uncertainty U.
I don't like best.
Because I don't
Central
want to,
value or primary value?
Because here two natural names are center and mean. But of course, once we deal with the asymmetric case, they are not good names. Because people may expect we center.
No, why don't we just say represents an uncertain number with value X and uncertainty U?
That's fine. That's fine.
I think that's what we should do.
Okay. So best is something I've taken from the literature. It's used sometimes.
That's not. I mean, let's just have best value and the keywords here.
Okay.
I'll put it in there. Okay. Okay. Great.
Okay. Yes. So then you recently have requested.
Oh yeah, I thought flattenable is a better. We've got several things that have come in recently for ILD. We're not going to have a chance to review them right now.
Right.
But I think flattenable is a better name for what we were calling flattened.
Right. The last name we came up with was flattened in.
Yeah, I know. I prefer flattenable to that. And there's a new idea, which is a tally idea. This is this idea of replicated 7, which is basically a way of parameterizing listability. So that would happen by default. Replicated 7 means you replicate it into that list, if you understand what I'm saying.
I see.
So for example, this, if I were to say replicated 7, 8, that would do 5 plus the list 7, 8, 6 plus the list 7, 8. Isn't that a nice idea?
What about if we have symbolic stuff? We have V. So a related problem that we have had other times is what happens if I know V is a vector, but I need to hold the sum temporarily so that I can replace V later.
Yeah, I understand. That's unreplicated. That's the opposite. Okay, let's schedule this for a different meeting.
Right.
And flattenable also.
Okay.
I don't think I can look at these right now, geodistance scale and so on.
Yeah, it's a long discussion. So I just had it there in case we had plenty of time.
Right.
So the concepts here are clear. There is one little thing which we need to discuss, which is this is a quotient, and we need to discuss, decide whether it's one way or the inverse. Because the way this is typically done in cartography is in the way in which large-scale maps correspond to small scales, which is horrible. And it's mentioned in the Wikipedia page that this leads to confusion. So my suggestion here is to have the reverse, so that large-scale maps correspond to large geodistance scales.
Well, I don't know what a geodistance scale is, but maybe a geodistance ratio would be a better name, but I don't know what it is. It doesn't look like a ratio, actually.
It is a ratio because the map coordinates, it's basically the distance that corresponds to 1 in the ticks of the map. The scale that is typically represented as 1 colon 100,000, of course, it assumes that you have a paper map that you can multiply by 100,000.
Okay, well, geodistance scale is an awful name for that. I mean, if that's 1 unit in the Mercator map.
So
Right.
it's a ratio. You have to multiply your unit of the map to get the actual distance.
Yeah, I mean, it's like the geogrid position stuff. It is going from, right, grid coordinates are the ones on the ground as compared to, how does it relate to geogrid position?
Yes, it's basically the question of geogrid divided by geo or geo divided by geogrid. So
I understand. So this is the units of geogrids.
Right, if you want. So miles here, so geodistance scale is now defined as geo divided by geogrid. So it's how many miles in the actual Earth divided by how many units in your map.
Right, right.
But unfortunately, traditionally is defined in the opposite direction, and it's called some things like point scale.
Okay, we need to, I mean, we need to have a separate discussion here. I mean, this is basically, I don't understand what the one unit is. How are you saying what the unit is here?
It's the geomodel. If you say the geomodel is the moon, then you will get a slightly different.
Yeah, but what's the, I mean, there must be a division of the Earth into some number of, pieces, right? How do I know what
that's the map. So the size of the Earth is controlled by the geomodel option. And then the size of the map is controlled by one of the parameters of the projection, which has a default. For example, for Mercator, longitude is given as degrees. So these numbers that you are seeing here.
Oh, I see. It's a degree. Okay, so that means this is a degree in the northeast direction. This is what a degree, because lat long are both in degrees.
Right. But there is a slight problem here, which is that the projections distort these things. So Mercator, for example, doesn't touch longitude, but it modifies latitude. So these numbers that we see here are not real latitude, because Mercator sends the pole to infinity in quotes latitude.
Yeah, but I mean, the fundamental units are degrees. I mean, it seems like geodegree distance would be a better name, but something like that.
It's degree for Mercator. For other projections, maybe radians. It depends on the parameter that you can choose freely in the projection. So it's a question of what you do on the Earth and what you do on the map, and you have the full freedom of choosing both.
Okay, how about geoprojection scale?
It's called distance because there is a separate function to do exactly the same thing for area. So there is a geo area scale. So sometimes when you are integrating area over a map, you need to know this relation for area.
All right, to be discussed. Don't know a solution.
Yeah.
Mm-hmm. Okay, great. All right. Talk to you all soon then.
Okay.
Okay. Bye. Bye. Thanks.